Today we're talking about composite figures. Composite figures are complex shapes made from simpler shapes. So you don't have specific area formulas for these, but since you have already memorized all of your area formulas, you should be able to use them to find the area of these more complex shapes. So to find the area of the complex shape, you have to find the area of each simple shape, and then you will add all of those areas. All right, so example 1, it says find the area of the composite figure. More often than not, the most difficult part of this is splitting up the shape so that you're able to find any missing sides. So we're going to start with breaking it down into two different rectangles. I'm going to split it right through here because I can easily see that 6 and 4 are the dimensions of that rectangle. So 6 times 4 is 24. Filling it in the boxes as you go is a really good strategy to make sure that you don't get any overlap and that you don't miss any of these shapes. So 6 times 4 was 24. We're talking about area, so it's 24 inches squared. The second shape that I have over here is another rectangle. So my length, which is the long side, is this 11, but my width, I'm not sure. I know the very top of this from one corner all the way over to the other was 20, but it doesn't tell me this missing side. This is where you have to go through with the information you're given to find some of the other dimensions if they haven't given them to you. So if the whole thing here was 20, but I knew that this part was 4, then to find this side, I'll do 20 minus 4 to get 16. Now I can go to my handy dandy calculator, do 16 times 11, because length times width will give me the area of that rectangle, and I end up with 176. Keep in mind we're still talking about area, so it's 176 inches squared. Now to find the composite area, or this one plus this one, I'm going to add the 2. So I have 24 from my first rectangle, 176 from my second rectangle, and 24 plus 176 is 200 inches squared. For this second problem, once again, we're finding the area of a composite figure. This one is a little more difficult to break apart though. If you look over here, you can see I don't have a line that goes across, but I can create one to make a triangle, a square, and a semicircle. So I'm going to start with the triangle. Keep in mind if you don't know those formulas, you do need to know the formulas before you are able to solve any of these. So formula for a triangle is 1/2 of base times your height. So I take 1/2 times my base, which was right here, and I knew that if this side of my square was 10, then this one was also 10. So 10 by 7. Your height of your triangle is always the very bottom to the very top, or the side that is perpendicular to your base here. That's where I got the 7. Go to your handy dandy calculator. You can do 1/2 times your base of 10 times the height of 7. So the area of that triangle is 35. 35, and it's yards this time, so 35 yards squared. It's still area, so we still square our answers. The square is probably the easiest part to pick out of there. So we have a side of 10 here and a side of 10 here, and 10 times 10 is 100 yards squared. So this one is 100 yards squared. By far the most difficult part is this semicircle over here. You don't have a formula for an area of a semicircle, but you do have a formula for the area of an entire circle. So you can find the area of the whole circle, and then we're going to divide by 2 because we only need half of that circle. For this problem, you may need to take out a piece of paper, or hopefully you're doing this in your notebook and you can scratch some notes over on the side. Again, you have to know your formulas to be able to do this. So I'm finding the area of a circle. And to find the area of a circle, I'm going to do pi times radius squared. Keep in mind, we're going to use 3.14 for pi unless it tells us otherwise. And the problem here is it gives me diameter, which is all the way across this circle. Well, if I knew that my diameter was 10, I have to find the radius. Radius times itself. If diameter was 10, then my radius has to be 5. Half of the diameter is the radius. Now I can take and multiply pi times my radius, so 3.14 times 5 times 5, and I end up with 78.5 yards squared. Here was my radius, and I ended up with 78.5 yards squared. That's for the area of an entire circle. In this case, I only need half of the circle, so I'm going to take that 78.5 in my handy dandy calculator and divide it by 2, because I only need half of the circle. So I took my entire area and divided by 2 to get 39.25. Still in yards squared because we are still talking about area. 39.25. So you see, by filling all of these in, I make sure that I don't end up with any overlap. Now I can add the area of my triangle, my square, and the semicircle in my handy dandy calculators. 135 plus 39.25 to get 174.25. Example is number 3 is a little bit different. It's dealing with negative space. If you think about it, when we talk about negative numbers, it's the same thing as when you subtract. You're going to do the same thing with the negative space here in this problem. So it's like taking a trapezoid and taking a pair of scissors and cutting away a semicircle and cutting away a square. So you're going to start by finding the area of a trapezoid. Again, you have to know those formulas. If you don't, use your formulas, notes, or use a friend, something, help somebody out, but you have to know these. So you have base 1 plus base 2 divided by 2 and then times the height. Keep in mind your base 1 and base 2 are always the parallel sides. So it has to be the bottom here and the top. Base 1 I'll use as 12. It's pretty easy to find. Base 2, I have to fill in some missing information. So base 2 goes from this corner all the way across to this corner. And it's given me enough information that I can fill in to find it. So from here to here was 2, plus the diameter of this circle, so 4. So 2 plus 4 is 6, plus one more over here is 7. I'm going to divide that by 2, so I end up with 19 divided by 2. And then I need to find my height. Your height is always the side that is perpendicular to those bases, so it is 8. Again, you're doing this part of the math on your notebook over on the side. So you have 19 divided by 2 is 9.5 times 8 is 76. And we've got yards again, so 76 yards squared. Now we're going to need to take away the square and the semicircle. So we're going to start with the square. Your square was 4 times 4 because you have length times width. So 4 times 4 is 16 yards squared. And for your semicircle, we're going to start just like we did last time. We're going to find the area of a circle first, and then divide it by 2 because we only need half of that semicircle. So we're going to use pi r squared to find the area of that semicircle. Keep in mind, unless it tells you otherwise, you're using 3.14 for pi, times your radius, but this problem doesn't just give us radius. What it does give us is diameter. If your diameter is 4, half of that is your radius. So your radius is 2. Now back to the handy dandy calculator. You have 3.14 times 2 times 2. The area of an entire circle would be 12.56. But we only need half of that circle, so we're going to divide that by 2. And the area of our semicircle is 6.28 yards squared. 6.28 yards squared. If you have a hard time seeing that these two are negative space, you may want to go ahead and put a little negative sign in front of both of them. That way you remember that those are your negative space shapes and to subtract them away. So to find the area of this composite, we'll take the area of the trapezoid, then we're going to subtract the area of the square and the area of that semicircle. Going back to your handy dandy calculator, the area of the trapezoid was 76, minus the area of the square, which was 16, minus the area of the semicircle, which was 6.28, and the total area left after you've cut out those spaces is 53.72 yards squared. For the last problem, you've got a little bit of positive space and a little bit of negative space going on. So this trapezoid here in the middle is all positive space. It's like you've taken and cut away the square that's in the middle, so that's your negative space, is that square in the middle. You may want to color yours so that it's a little bit easier to see. And the semicircle is also positive space. So if you shade it in, sometimes it makes it a little easier to see. You'll be adding the semicircle, adding the trapezoid, subtracting the area of the square. Go ahead and solve for your check. Don't forget your units in feet squared, and good luck.